Hello and welcome back to another AP3 video, and in today's video we'll be going over SAT math problems, more specifically problem solving and data analysis. We're going to be doing easy to hard questions in today's video. Now, the question asks the following: a printer produces posters at a constant rate of 42 posters per minute. At what rate in posters per hour does a printer produce the posters? Okay, so we're given that there's a constant rate of 42 posters per minute. So let me rewrite that in blue. 42 posters per minute. And what we're looking for is what is the rate in posters per hour. So how can we rewrite the conversion, or how can we convert it into posters per hour? Well, remember, in 1 hour, how many minutes are there? 60 minutes. So what we can do is that we can do 60 minutes per 1 hour, cancel out the minutes, and we can get a constant rate of posters per hour. So we can multiply 42 posters per minute by 60 minutes per hour. So 1 hour. So now we can multiply. The terms minute cancel out, and then we write 1 minute for blue. So every minute there's 42 posters. And then what we can do is multiply 42 posters times 60 and 1 times 1 hour to get the constant rate of 42 posters per hour. So we write that as 42 multiplied by 60 posters and divided by 1 minute, or 1 multiplied by 1 hour, because the minute the minutes cancel out. So you can do it mentally, or you can use a calculator, because remember, Desmos offers a calculator. And if you do 42 times 60, you should be getting the number of 2,520. So per every hour, there's 2,520 posters created. So posters per hour. And that is our answer right here. Okay, let's do a different question now. A group of monarch butterflies migrated from Chicago to Mexico, flying a total of 2,100 miles. It took a single butterfly in a group 120 days to travel this route one way. On average, how many miles did the butterfly travel per day? So we're given a few measurements. We're given that the butterflies migrated from Chicago to Mexico, flying a total number of 2,100 miles. And it took one single butterfly 120 days to travel to this route one way. So from Illinois to Mexico, it took them 120 days to get there. And they're asking you the average of how many miles did the butterfly travel per day. So butterfly travel per day. So let's use what's given. So we're given 2,100 miles that they migrated from. And it took them about 120 days to get there. And we're looking for the average of miles per day that one butterfly migrated to get there. So how many miles do we have? 2,100. How many days did it take them to get there? So 120 days. So what we want to do is divide 2,100 miles divided by 120 days to get the average on how long did the butterfly travel of miles per day. So we can rewrite it as 2,100 miles divided by 120 days. And we're going to get a number, miles per day. So if you plug that into a calculator, you should get 17.5. And that is our answer, because this gives us the average of how long did the butterfly travel of miles per day. So the answer is C. Okay, let's do like a conversion type of question. How many yards are equal to 612 inches? Okay, so we're given that there's a total number of 612 inches. So 612 inches is given. And we want to convert that into yards. So we want to convert that into a number of yards, which is equal to the number of inches. We're given that 1 yard equals 36 inches. So I'm going to rewrite that in red. So 1 yard equals 36 inches. So what can we do? What can we do is that we can divide 612 inches divided by 36 inches and then get a number of yards available of how many yards are in 612 inches. So we can write it as 612 divided by 36. So as the equation that I wrote, 612 inches divided by 36 inches. And we're going to get a number of yards. And if you plug that into a calculator, so you do 612 divided by 36, that'll give you 17. So how many total yards are there in 612 inches? That'll give you a number of 17 yards. So the answer is B. Now, it is important to know that sometimes you really can do mental math, so it's easier to plug it into decimals or any type of calculator that's given or that you brought into the test instead of like doing it mentally, because you don't know what other type of questions that they're going to be offering you in either module 1 or module 2 that are going to be really hard, or that's going to make you struggle, so you don't know how to solve it really quickly. Okay, let's do medium questions now. As we can see in this question, there's a little bit of American history. On April 18, 1775, Paul Revere set off on his midnight ride from Charlestown to Lexington. If he had ridden straight to Lexington without nonstop, meaning at a consistent rate, he would travel 11 miles in 26 minutes. Let me highlight that. 11 miles in 26 minutes. In such a ride, what would the average speed of his horse have been to the nearest tenth of mile per hour? Okay. So besides 11 miles in 26 minutes that he went to Lexington nonstop, so at a consistent rate, we're looking for the average of speed of his horse have been to the nearest tenth of a mile per hour. Okay, so let me write what's given. So we're given that he traveled 11 miles in 26 minutes if he went nonstop to Lexington from Charlestown. And we're looking for the average speed of his horse to the nearest tenth. So the nearest tenth basically means that we're going to have to round in this type of question. So anytime you see to the nearest tenth, 100th, or 1000th, you're going to need to round in those type of questions, like one over here. So I'm going to rewrite 11 miles in 26 minutes as a fraction. So 11 miles per 26 minutes. So what we can do is that we can convert minutes into hours as we did in the first question. Multiply by 60 minutes per 1 hour to cancel out the minutes, and then we're left with 11 miles multiplied by 60 and divided by 26 times 1. So we multiply 60 minutes per hour, so divided or per hour, 1 hour. And now we multiply. The minutes cancel out, and what we do now, this equals 11 times 60 miles divided by 26 multiplied by 1 hour. So now let's get our handy calculator, and if we do 11 times 60, we should get 660. 660. So we get 660 miles, and then divided by 26 times 1 hour. So that just gives you 26 hours. So 26 hours. And this is our average. So I'm drawn in green. This equals our average. However, they're asking us for the nearest tenth. So what we do is that if we do 660 divided by 26, you should get like 25.3846. And that is a huge decimal, because this equals 25.3846. So, and they're asking us to round to the nearest tenth. So all I have to do is look for the nearest tenth, which is the 3 right over here, and round it up. So as we can see, there's an 8. So 25.3846 rounds up to 25.4, and that is the average to the nearest tenth, and this is our answer. So 25.4, let me rewrite that as with the conversions or like the measurements, because that is very important. So 25.4 miles per hour. And this is our answer. Okay, let's do a different question now. The table shows the amount of protein in 2 foods and the cost of each food. Based on the table, what is the ratio of cost per gram of protein in large to the cost per gram of protein in a cup of milk? So we're given a graph. So we see 1 large egg. 1 large egg equals 6 grams, and the cost is 0.36 cents. For 1 cup of milk, it's 8 grams of protein, and it costs us 24 cents. And they're looking for the ratio of cost per gram per protein in a large egg, and then cost per gram of protein in a cup of milk. So what we're looking for is cost, or money, per gram or gram of protein. So let's see large egg. So I'll make it in green. Large egg. So I'm given that there's 6 grams of protein. So 6 grams. So 6G. And it costs, so money costs 0.36. And we want it in cost per gram. So I get 36 cents and divide it. And I divide it by 6. So 0.36 divided by 6. I'm going to get 0. Remember, you want to plug it into a calculator. So if you do 0.36 and divide it by 0.36 and you divide it by 6, you get 0.06 costs per gram for a large egg. So let's do 1 cup of milk. So cup of milk over here. So for cup of milk, I have 8 grams. And I have 0.24 costs. So same thing. So I do 0.24 and I divide it by 8. That equals 0.03 costs per gram. And we're looking for the ratio of large egg to 1 cup of milk. So per cup of milk, and both cost per gram. And cost per gram for milk, or for an egg, sorry, is 0.36. So 0.06, sorry, of G per C. So it costs per gram. So let me rewrite that. That was my mistake with the measurements. So it'll be 0.06 cost per gram, and then I'll divide it by 0.03 cost per gram of a cup of milk, and then that equals, if we divide it by 0.03 on both sides, I'm gonna get 2/1. So for every 2 large eggs, there's 1 cup of milk cost per gram, and that is the answer to D. Don't get confused with 1/2 or 1 per 2. That would be 1 large egg per 2 cups, but in this example, it's 2 large eggs per 1 cup of milk. Okay, let's do a different problem now. A triathlon is a multi-sport race consisting of 3 legs. A triathlon participant cycled the cycling leg with an average speed of 19.7 miles per hour. What is the average speed in yards per hour of the participant during the cycling leg? So the triathlon cycled an average of 19.7 miles per hour, and we're looking for the average speed in yards per hour of the participant during the cycling leg. Okay, so we're given that 19.700 miles per hour. I'm gonna convert it into a fraction, so 19.7. You don't need to write the zeros. Miles per hour, or divided by an hour. Okay, and we're also given that per every mile there's 1,700 yards. So 1 mile equals 1,760 yards. So what we want to do is take away the miles, or convert the miles into yards to get yards per hour. So like we've been doing in the previous questions, we're gonna do the same thing here. We're gonna multiply. So where does miles go? Is it numerator or denominator? It would go on denominator, so we can convert the miles into yards. So we would get, So we would get 1 mile, and 1 mile, there's 1,760 yards. The miles cancel out, and then I'm left off with 19.7 multiplied by 1,760 yards divided by 1 hour. So if I were to multiply 19.7 times 1,760, so 19.7 times 1,760, you should get, if you plug into a calculator, 34,642. So that equals 3,672 per hour. So yards per hour. Yards per hour. And they're asking us how much did the participant during the cycling leg average in yards per hour. That would be, again, 34,672 yards per hour. All I did was just convert the miles into yards, and that's why I got the answer. Okay, now we're moving on to hard problems. These problems are going to be the same thing, but a little bit different. Notice what they're asking you. A certain town has an area of 4.3 square miles. What is the area in square yards of this town? So we're given one measurement, and besides what we're looking for, we're given 4.6 squared miles. So 4.36 squared miles. And then they're asking for square yards. Why am I saying squared really weird? Because remember, squared is for example, if I say x squared, I have x to the power of 2. In this case, squared miles can be miles to the power of 2. And this is important in order to figure out to convert it into yards squared. So what am I given? 1 mile, which I'm going to highlight it in red or yellow. 1 mile equals 1,760 yards. So 1 mile equals 1,760 yards. So I'm going to convert 4.36 squared miles, and I'm going to rewrite it as 4.36 miles squared. Like that. I hope that makes sense. I'm just rewriting it for you guys to understand what I'm about to do. So if you're looking for squared miles, we got to convert 1 mile into 2 miles or miles squared to get yards squared. So if I do 1 to the power 2, I get 1. So equals, I got to do 1,760 squared. So 1,760 squared, I get 3,097,600 yards squared. So I get 3,097,600 yards squared. So squared yards. You can say one or the other. So all I have to do now is to understand that for every 1 mile or squared mile, there's 397,600 squared yards per squared mile. So now what I have to do is, and this looks a little bit weird, I have to divide squared mile and then multiply the 3 million squared yards to get the answer. So 4.6 miles squared multiplied by 30,097,600 yards squared divided by miles squared. So then 4.36 times the 30 million, so 4.36, I get the answer of 13,505,536 yards squared, or squared yards. And the only answer that looks like that is D. Okay, let's do a different question compared to the ones that we did today. If 4a divided by b equals 6.7 and a divided by bn equals 26.8, what is the value of n? So I'm given two equations. I'm given that 4a divided by b equals 6.7 and that a divided by bn equals 26.8. And we're looking for the value of n. Notice how both equations give you ab. What we're going to want to do is get AB on the yellow highlighted by itself to plug it into the highlighted equation of A divided by BN to find the value of BN and then solve for N. And we get to get the value of AB to solve for N. So 4A divided by B equals 6.7. So if I divide 4 on both sides, so divide by 4, that equals A divided by B, which equals 6.7 divided by 4, and we found our value of AB. But if we make that into a fraction, 6.7 divided by 4, I am going to get 1.675, which equals 1.675. Let me get the second equation now. So I have A over divided by B multiplied by N, which equals 26.8. Remember, we said that AB equals 1.75. So I can rewrite this whole equation as, so this equals 1, so let me rewrite it. So that equals, 0.8, 1.675 divided by N, which equals 26.8. And now I have to solve for N. If I multiply N on both sides, N's cancel out over here, and then I'm left off with 1.675, which equals 26.8N. And if I divide both sides by 26.8, I'm left off with N on the right side. So it's 26.8. So I get N equals 1.675 divided by 26.8, and now I find my value of N by dividing both on a calculator, because honestly you really can't do this mentally because there's a lot of decimals, and this is probably like a huge decimal, if not really short. So 1.675 divided by 26, so 1.675 divided by 26.8, we should get 0.0625, and that is our answer. So N equals 0.0625. Okay, let's do the last example of today. The sample of an oak tree has a density of 800 kilograms per cubic meter. The sample is in the shape of a cube where each edge has a length of 0.9 meters. To the nearest whole number, what is the mass in kilograms of the sample? Okay, so we're given that it has a density of 807 kgs per cubic meter. So 807 kgs per cubic meter. Per cubic meter. And they give us that it's in the shape of a cube. Over here, and it tells us that each edge, I'm not really the best at drawing, but that's like how I think a cube looks like, or how I draw a cube. And they tell you that each edge has a length of 0.9 meters. So 0.9 meters per edge in the cube. And we're looking for the whole number in kilograms of the sample. So what we have to do is multiply the 0.9, or get to 0.9 and multiply it by itself 3 times, or cubic, because we got to convert each edge to cubic meter. So we do 0.9 cubed, or to the power 3, to get cubic meter. And if we do that, so 0.9 meters, and then we multiply the power 3, we should get 0.9 to the power of 3, which equals 0.729 cubic meter. So now what we have to do is, like we've been doing for the whole video, of converting, taking out the cubic meter to get kilograms by itself. So 0.729 cubic meters. So cubic meter. And then multiply that by 807 kilograms divided by cubic meter. The cubic meter cancels out. And then I'm left off with 807 kilograms multiplied by 0.729. So you multiply 0.729 multiplied by 807, and you should get a total number of 588.333. So 588.303 kilograms, or kgs. And they're asking us what is to the nearest whole number, so it would just be 588. The answer would be A. This is the last question for today. Thank you for watching, guys.